Recapture method is used to estimate a population when it's impossible to actually count the entire population. There is a formula, so that's one way you can use it. So the population size is equal to the number first captured in the first sample times by the number recaptured in the second sample, and divided by the number that were recaptures that were marked or tagged in some way. We'll do some examples in a minute and I'll talk it through in a slightly different way, but you can just memorise the formula if you want to. Now, they often in questions ask you to state the assumptions that you're making for this method. And the two primary ones are that the samples must be taken randomly and in the same way both times, and that the population size hasn't changed between the first sample where they were captured and the second sample where they were recaptured. Now, other assumptions you might think of is that you have to assume that none of the marks or the tags have got lost between the two samples. You've got to assume that capture and tagging doesn't affect the population. And also you've got to be able to accurately count for your sample. So those are some of the types of assumptions, but it's normally the top two there that they will be looking for. So if a random sample of 100 fish in a lake is taken and each of the fish caught is marked with a waterproof dye and then released, and a second sample of 200 fish is taken and in that sample 3 are marked, estimate the total number of fish in the lake and state any assumptions. Okay, so what do we know? We know that of the second sample there were 3 out of 200 that were tagged. This tells us the proportion of fish in the lake that are tagged. So 100 were tagged, so 3 over 200 is equal to the 100 fish. Now what we want to know is how many fish there are in total. So instead of a fraction we want a whole one. So a whole one would be the same as 200 over 200. So if 3 over 200 is 100, 1 over 200 as a fraction of how many are in there would be 100 divided by 3, and therefore 200 out of 200, i.e. all of them, would be that 100 divided by 3 times by 200. And if we work that out, we'll get 6,667 rounded to the nearest whole fish. And since this is an estimate, there's no point trying to be fancy and accurate with it because that is inappropriate in this circumstance. So always round to the nearest whole one because that's the only sensible thing to do really in the situation. So what assumptions have we made here? So I talked about them in the previous slide. So the two assumptions we've made, the most important one probably is that the population hasn't changed, and 2, that both samples were done in a random way, so they're random sampling and they were done in the same way both times. So let's do a different example. Here we've had a random sample of 20 bats were taken the first time. Each bat was tagged and then released. And a second random sample was taken of 25 this time, and 6 of the bats had tags. Estimate the total number of bats in the roost. So the proportion that had tags, 6 out of 25. This time I'm going to take that in a different route. So 6 over 25 would be the same as 24 over 100. In other words, 24%. So if 24% is equal to the 20 bats, then we need to get to 100%. So 1% would be 20 divided by the 24. 100% would therefore be 20 divided by 24 times by 100, and that works out to the nearest whole bat to being 83 bats.